Okay, today we're going to go over how to find and graph with slant asymptotes. So let's look at our first example. We're going to graph, identify asymptotes, intercepts, and holes if there are any. Okay, so on this one, our vertical asymptote comes from the denominator. So that's x equals -1. So I'm going to go ahead and draw this in. Then I'm going to look at the degree to determine what the horizontal asymptote is, or if it's a slant asymptote. So in the numerator, that's 1 and 1, so degree 2. In the denominator, this is to the first power, so this is degree 1. So now we have one where the degree on top is bigger. So that means that there is a slant asymptote. So to find it, you've got to divide this out. So you can either do that with long division or synthetic division. It doesn't matter. I'm going to do synthetic division because when we are graphing rational functions with slant asymptotes, we are always going to be left with a linear factor in the denominator, meaning degree 1. So you can always do synthetic division when you're finding the slant asymptote for rational functions. But no matter how you divide this, you need to always multiply out the numerator. So this is going to be x squared, that's plus 3x minus 5x, so minus 2x minus 15. Okay, so your numerator's got to be completely multiplied out before you can do synthetic division. So remember, what goes in the box is what's in the denominator, -1. It's always going to be the same as the vertical asymptote. Then your coefficients, make sure you have all your degrees and you're not missing anything, and it's in order. And in this case it is degree 2, 1, and then degree 0. So then you're just going to write your coefficients. And then bring down the 1 first, and then multiply this by the -1 in the box. So 1 times -1, -1. Then you add going down, -2 plus -1, -3. Multiply the -3 by the -1. That's going to give me +3. And then a remainder of -12. And the good news is we don't care about the remainder. So once you get this second term, you can stop. So these are our new coefficients. So we started at x squared divided by an x. So I'm now at x to the first. So this makes my slant asymptote y equals x minus 3. Okay. So the slant asymptote is always just going to be a line. So we're going to graph that line. Okay. So the y-intercept of this line is -3. Okay, and that's the y-intercept of the slant asymptote. It's not the y-intercept of this rational function. And then the slope of this line is 1. So that means I'm going to go up 1, right 1. And you always want to graph your slant asymptote, so you're just going to keep going up 1, right 1 until you've gotten to or past the x-axis. And then I'm going to go down 1, left 1, and I want to reverse it until I've gotten to or past my vertical asymptote. So you always want to make sure you graph enough points of the slant asymptote so that you get to the x-axis and to the vertical asymptote. And then your slant asymptote will just go through these points. I'm going to make this one a little longer, and you should always have 4 sections that look kind of like this. These 2 kind of triangle-y looking ones, and then these 2 wider ones. Then I'm going to go ahead and graph my x-intercepts, which are going to come from the numerator, so 5 and -3. So I have an x-intercept at 5, 0 and -3, 0. They're both to the first power, so I'm going straight through them, not bouncing off of them. My y-intercept, I'm going to plug in 0, so that's going to give me -5. For the first factor, 0 plus 3 is going to be 3. 0 plus 1 is going to be 1 on the bottom. So -15. And then there were no holes on this one because there wasn't something we could cancel on top and bottom. So my y-intercept is going to be somewhere down here. And again, as long as you have it listed out somewhere, you don't have to mark all the way out to -15 if you don't want to. So then to graph it, the nice thing about slant asymptotes is the two pieces to the graph, they're either going to fall in this little skinny triangle part or in the wider outside parts. And you can tell based on where your points are. And our points are in those wider sections, so that's where our graph is going to fall. Okay, and just like when you graph a rational function with a horizontal asymptote, we always start parallel to the horizontal asymptote. Well, now we're going to start parallel to our slant asymptote. Okay, and I'm starting in this outside section because this is where my points are. And again, I'm above the x-axis because my leading coefficients are positive. So I'm just going to start parallel to my slant asymptote. I'm going to go through that point. Kind of had to turn a little bit. You're going to go through your y-intercept and again end up parallel to the vertical asymptote. So sometimes, well, I have a hard time drawing these shapes. Sometimes they look a little weird, but as long as you're going through your points and ending parallel to your slant and vertical asymptote, you're good. And then on the other side, I'm going to start away from it because this was an odd asymptote and that's where this point is. I'm going to start parallel to the vertical asymptote, go to my x-intercept, go through it, go to my slant asymptote, end up parallel to it. Okay. So in this one, the two parts fell on the outside part. So let's go ahead and do one more example. So we've got y equals negative 2x cubed plus 5x squared minus 2x all over x squared minus x minus 2. So the first thing we need to do is factor both the top and bottom. So on the top, I can go ahead and take out a negative x. I always like to have the first term of the squared part be positive. I think it's easier to factor. So that's going to leave me with 2x squared minus 5x plus 2, and then I'm going to factor both of these trinomials. So this is going to be negative x. The 2x squared will factor into 2x and x. Okay, the positive 2 is going to factor into minus 1 and minus 2. The 1 is going to have to go with the 2x. I can't put the 2 here because there'd be a GCF, and there's no GCFs here. So minus 1, minus 2. And then this one on the bottom is going to factor into x plus 1, x minus 2. So I can see I have a hole right here because these two factors match. So I can cancel that. And then I'm going to go ahead and write down that means there's a hole at 2 something. So to figure out what the y value of the hole is, you're going to use what's left of the function. So I'm using this circled equation to graph everything. So I'm basically done with the original. Okay, so I'm going to go ahead and finish figuring out what the hole is because I usually forget that if I don't do it right away. So I'm going to plug 2 into what's left to find the y value of the hole. So that's going to give me y equals a negative 2. 2 times 2 is 4, minus 1 is 3, all over 3, and I can cancel the 2 3's. So that's going to give me a hole at negative 2, or sorry, at positive 2, negative 3. So that'll just be a little open circle in our graph. Okay. Now my vertical asymptote, that's going to be the denominator. That's going to be x equals negative 1. This one again is going to have a slant asymptote because the degree on top, and again I'm looking at the simplified one. That's to the first, that's to the first, so that's a degree of 2 on top. That's a degree of 1 on the bottom, so it's a bigger degree on top. Even if you look at the original one, the higher one, the bigger one, the bigger degree is on top. Then my x-intercepts, oh, I actually need to find the slant asymptote, so let me go ahead and do that. Okay, so what's in the denominator, that 0 always goes in the box. So I'm going to have a negative 1 there. Remember, you have to multiply out the numerator. So when I distribute that negative x, that's going to give me negative 2x squared plus x, and then I don't have a constant term. So my coefficients are going to be -2, 1, and 0. I'm going to bring down the -2, multiply by the -1, add going down, multiply by the -1, but then I don't really care about this because you don't care about the remainder, you just really need the first two. So this is going to be -2x plus 3 for my slant asymptote. Okay. So let me go ahead and graph those. So I've got x equals -1. For my slant asymptote, the y-intercept of the slant asymptote is at +3, and the slope is -2. So I'm just going to go down 2, right 1, until I get past the x-axis. And then I'm going to reverse it. I'm going to go up 2, left 1, until I get to or past the vertical asymptote. And then I'm going to go ahead and draw my slant asymptote through those points. Okay. And then I'm going to graph my x-intercepts, which come from the top. So from the x, that's just going to be a 0. From the 2x minus 1, add 1, divide by 2. That's going to give me another x-intercept at 1/2, 0. So my x-intercepts will be at 0, 0, 1/2, 0. The y-intercept, since I have an x-intercept at the origin, that means the y-intercept is also there. But if you plug in 0, that's going to give you 0 times -1 over 1. You would still get 0 by plugging it in. And then I'm going to graph the whole, which is going to be an open circle at 2, -3. So this one I can see my points fall in this little skinny triangle section, so that's where the graph is going to be, in these two sections right here. Okay, but again, you can always just follow the same rules. My leading coefficient is negative, so I would want to start below the x-axis, but I would want to start not between the x-axis and the slant asymptote, but below the slant asymptote, because that's where my points are. So I'm going to start parallel to the slant asymptote. I'm going to go through the hole, through the x and y intercepts. I'm going to go through this one, turn around, go through the other one, and then end up parallel to the vertical asymptote. Then on the other side of this vertical asymptote, I'm going to start away from it. And then you're just going to have a little piece in the little section on top. And that is it. So you have a couple graphs if you need some practice with this. And then there is a review worksheet for rational functions. And that is what you will be turning into us on It's Learning.